Hello, geometry students. Today we are going to learn about arcs and chords. Points on a circle determine both chords and arcs. Several properties are used to relate points on a circle. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding arcs are congruent. So if RS, the arc, is congruent to TV, the arc, then our segment RS, this chord, will be congruent to this segment TV, this other chord. So congruent chords make congruent arcs, and congruent arcs make congruent chords. All right, so now we've established that, let's work some practice problems having to do with arcs and chords. Let's start with number 1. It says, find the value of x in each circle. And x is an arc on the circle. Do you see the congruent chords pictured? They have the tick marks here and here. That means this is also x degrees because arc SR is going to be congruent to arc ST. So if you take 360, which is the total degrees in a circle, and you subtract 64, because that's how many we are given, that's going to give you, let's see, 296. That's what's left for both of these, and since they're the same, we divide by 2, and we get 148 degrees for this arc from S to R and this arc from S to T. All right, let's take a look at number 2. We have this arc is 116 degrees from F to G. There's a congruent chord from F to G and D to E. That means the arc from D to E is also 116 degrees. And they want to know how many degrees is the central angle from D to the center to point E. Well, a central angle is congruent to its intercepted arc. So that means x is 116 degrees. Easy peasy. All right, let's go down to number 5 now. Skip a couple. Number 5 has congruent arcs on the outside of the circle, and we know one chord is 18 and the other is 2x plus 4. These chords have to be congruent since the arcs they intercept are congruent. So we can write an equation, 2x plus 4 equals 18, and use that to solve for x. So we can subtract 4 on both sides, 2x equals 14, divide by 2 on both sides, x equals 7. All right, let's take a look at number 6. On number 6, we have a 115 degree arc from J to H, and we have another 115 degree arc from I to H. That means these two chords are congruent. So we can write an equation. 2x plus 1 equals 5x minus 5. And we're going to get the x's together. So I'm going to subtract 2x on both sides. 1 equals 3x minus 5. And now I'm going to add 5 to both sides. So 6 equals 3x. And then if I divide by 2 on both sides, x is equal to, oh wait, divide by 3 on both sides, I apologize. Trying to cancel that 3, x is equal to 2. All right. Moving right along, we're going to skip a couple and go to number 9. On number 9, it says circle V is congruent to circle W. So these two circles are the same size. We have the arc from T to U is 162, and the arc from Z to Y on this one is 198. So it seems like there are no congruent arcs in this picture, but keep in mind, if I take 360 and subtract 198 from it, I get 162. So this is 162 here, and this is 198 here, which means that this chord TU is equal to this chord ZY. So I can write the equation 9x minus 78 is equal to 3x. And so I'm going to get my x's together, and I get 6x minus 78 equals 0. And then if I add 78 to both sides, I get 6x equals 78. And then if I divide by 6 on both sides, I get x equals 13. Okay? All right. On the other side, we have some properties having to do with diameters and chords. In a circle, if a diameter or radius is perpendicular to a chord, so like WO is perpendicular to AB, then it bisects the chord and its arc. So that means point X would be the midpoint of chord AB, and W would be splitting the chord from AB in half. So AW, arc AW, and arc WB would be congruent here. In a circle, the perpendicular bisector of a chord is the diameter or the radius. So if you know you are looking at the perpendicular bisector of a chord, so for example, they have a right angle and tick marks, then you would know for sure that the segment that was the bisector, the perpendicular bisector, was indeed a radius or a diameter if it stretches all the way across the circle. Last, it says, in a circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So chord AB can only be congruent to chord RS if the distance from O to X is equal to the distance from O to Y. All right, so let's use that information to help us solve some more problems. In circle P, the radius is 13, and RS is equal to 24. Find each measure, round to the nearest hundredth, okay? So first we have to find RT. Well, we know that RS is 24. And since this is the radius, it is the perpendicular bisector of this chord. Well, it's perpendicular, and it has to travel through the middle since it's the radius. So that means that RT is going to be half of RS. So we can just take 24 divided by 2, and that will give us 12. Now what about PT? Well, PT is this little distance here. In order to find it, we're going to have to make a little right triangle. We're going to have to connect P to S, which is a radius of the circle, and the radius is 13. And we know that S to T is 12, just like R to T was 12, because that's the other half of that chord. And then we're trying to find this distance PT, which I'm going to put a little X here for. So I'm going to use Pythagorean Theorem to do this. X squared plus 12 squared is equal to 13 squared. So x squared plus 144 equals 169. Subtract 144 on both sides. So x squared is equal to 25. Take the square root, and x is equal to 5. So you had to use the Pythagorean theorem here to do this one. Number 3, TQ. Well, to find TQ, we need to remember that PQ, the radius, is 13. And PT, we just found, was 5 from the last problem. So minus 5 for PT will give us 8 left over for TQ. All right, next section here. In circle A, the diameter is 12, CD is 8, the measure of arc CD is 90. Find each measure and round to the nearest hundredth. And look, it had said round to the nearest hundredth here, and we didn't end up having to round. So sometimes they tell you that just in case maybe you make a mistake and you're going to have to round your mistake. Okay, so the number 4, the measure of arc DE is this one right here. Notice that since we have this diameter of the circle at a 90-degree angle to this chord, that means it splits the chord and the intercepted arc into 2 equal arcs. So if the arc from C to D is 90, then the arc from D to E is going to be half of 90. 90 divided by 2 gives us 45 degrees. Now, we need to know how far it is from F to D. We know CD is 8, and F is this point here. It splits it right in the middle. So we're going to go 8 divided by 2, and we'll get 4. Now, from point A to point F, we have to figure this one out. We know FD is 4. And we know AD is the radius of the circle. The diameter is 12, so half of the diameter would be 6. And so we can use Pythagorean Theorem to find that missing distance from point A to point F. So we'll go x squared plus 4 squared equals 6 squared. So x squared plus 16 equals 36. Subtract 16 on both sides. X squared equals 20. Take the square root on both sides. X is equal to the square root of 20, which we will have to round. And it says to the hundredth, so we need 2 numbers after the decimal, 4.47. 4.47. is the length from point A to F. All right, number 7. In circle R, TS is 21 and UV is 3x. What is x? Notice that these 2 chords are equidistant from the center of the circle because the perpendicular distance from the center to the chord is 6 on both. So that means these are congruent chords. So 21 is going to have to equal 3x. So to solve for x, we just divide by 3 on both sides, and x is equal to 7. And here's our last one for today. In circle Q, segment CD is congruent to segment CB. GQ is equal to x plus 5, and EQ is equal to 3x minus 6. What is x? Well, if these chords, CD and CB, are congruent, then that means they have to be equidistant from the center of the circle. So the distance from point G to Q has to equal the distance from point E to Q. So I can say x plus 5 equals 3x minus 6 and solve this equation for x. So I'm going to subtract x on both sides. 5 equals 2x minus 6. Now I'm going to add 6 to both sides. 11 equals 2x, and then just divide by 2 to get the x by itself. So x is equal to 5.5, and that's the answer. All right, I hope you've had some fun learning about arcs and chords today. Good luck with your assignment. Please let me know if you need any help at all, and have a fabulous day. Bye for now.